A tank contains 1,000 liters of brine with 15 kilograms of dissolved salt. Pure water enters the tank at a rate of 10 liters per minute. The solution is kept thoroughly mixed and drains from the tank at the same rate. Part A, how much salt is in the tank after T minutes? Let's start by labeling a few things. We'll let Y of T be the amount of salt. And keep in mind that's in kilograms. And that will be after T minutes. We also know that Y at time 0 is 15. Again, kilograms. The amount of liquid in the tank is remaining constant, so amount of liquid that stays 1,000 liters at all times. We're adding water, but it's also being drained at the same amount. We can then label the concentration at time t. The concentration, we'll think of that as Y of t divided by the amount, 1,000. And that is, the units there would be kilograms per liter. Then dy dt, that is, let's think of that as the outflow rate of the salt. Outflow rate of salt. That's going to be equal to the concentration, Y of t, divided by 1,000. And again, the unit's kilograms per liter. That's the concentration. Times the flow rate. The flow rate, we are told, is 10 liters per minute. And we know that it's decreasing in salinity, so we'll make that negative. From here, we can simplify a little bit. We'll get dy dt is equal to negative Y of t divided by 100. Next, we'll separate the functions. Y of t I'll write as just y. So we have 1 over y dy, and that's equal to negative 1 over 100 dt. Now that we've separated the functions, we can integrate both sides. On the left, we get the natural log of y, and on the right, we get negative t over 100 plus the constant. At this point, we can use the initial condition, which we were told y at time 0 is 15. So let's plug that information in. We have natural log of 15 equals 0, I guess negative 0 over 100 plus c. So that means c is the natural log of 15. With that information, we can go back to the previous equation. We have ln y equals negative t divided by 100 and C we are now replacing with the natural log of 15. Our goal is now to solve for y. Since we have natural log on both sides, let's pull those natural logs over to one side to see if we can simplify that a little bit. So ln y minus ln 15 equals negative t over 100. Remember the log rules, we can now write that as ln of y divided by 15, which is equal to negative t over 100. Next, we'll exponentiate both sides. So the left side, we have e to the left side, and the same thing on the right side, we have e raised to the right side. On the left side, the e raised to the natural log, those essentially cancel each other, leaving us with just the argument y over 15, and that is equal to e raised to the negative t over 100. We can now multiply by 15 on both sides. Y is equal to 15 e to the negative t divided by 100. And we now have our equation. So this can measure the amount of salt at time t. Part B, so that was part A. Part B is asking how much salt is in the tank after 20 minutes. So we simply plug in 20. E to the negative 20 divided by 100, and throw that into your calculators, and we can confirm that that is roughly 12.3 kilograms of salt.